Welcome to the deep dive. Are you maybe staring down the barrel of the Cambridge A-Level Computer Science 9618 Paper 4 this June?
Yeah, feeling like you need to crack the code for that practical exam.
Exactly. Well, you're definitely in the right place today.
Absolutely. Think of this as, well, your strategic roadmap for Paper 4 success. We've really looked at the syllabus, the recent exams, basically getting you the tactics you need.
And, before we dive deeper, we should mention the fantastic resources from Zach. They're really essential backup.
Oh, absolutely. His YouTube channel is brilliant for explanations. Then there's the website, www.kazwithzach.com. Loads of materials there.
And don't forget the AskZ AI teaching assistant. We're part of that system, helping Zach help you.
That's us. Available on WhatsApp. The number's plus 923-362-810-241. And also the chatbot at bit.ly AskZ chatbot.
And it offers personalized learning, across all subjects, any language. Really powerful stuff.
Seriously useful tools. Okay, so let's zero in on Paper 4 itself.
Right. It's a unique beast, isn't it? It's purely about advanced problem solving and programming.
Directly from chapters 19 and 20 of the syllabus. That's the focus.
So all that stuff like low-level assembly language or, prologue.
Forget it for this paper. Set it aside. It's just not on the menu here.
Good to clarify. Okay, format-wise.
That's a 2-hour, 30-minute exam, 75 marks total.
And it's all done on a computer, right? Coding live.
Yep. In Java, VBNet, or Python. And specifically, Python in console mode.
Gotcha. And here's something really, really critical we need to stress.
Go on.
It's not just about writing some code. You need complete working programs.
Functional solutions, definitely.
But more than that, you absolutely must submit the evidence. Code listings, screenshots.
Showing your testing, it all goes in that evidence document.
And the examiners are serious. No evidence submitted could mean, 0 marks for a whole task.
Ouch. Yeah, treat that evidence document like gold. It's proof you did the work and it runs.
So true. Now, what about what they're actually assessing?
Yes. Paper 4 is 100% focused on Assessment Objective 3, AO3.
AO3. Okay, unpack that for us. What does it mean in practice?
It means design, program, and evaluate computer solutions.
So forget just memorizing theory.
Exactly. This isn't about reciting definitions. It's about doing. Can you design a smart algorithm?
Can you write clean, correct code?
Can you test it properly and deliver something that actually works? That's the core of it. Practical application.
Right. So let's map out the syllabus chapters again, chapters 19 and 20.
Yep. Chapter 19 is computational thinking and problem solving. This is your algorithms, searching, sorting. Definitely know those.
And abstract data types, ADTs, stacks, pews.
Linked lists, trees, even graphs potentially. And a big one that weaves through it all, recursion, master recursion.
Okay, then chapter 20.
That's further programming. It looks at programming paradigms, but the real heavyweight here is object-oriented programming.
Oh.
Classes, objects, methods, that whole deal.
You bet. And also file processing, reading from and writing to files.
And handling errors that might pop up, like a file not being there.
Crucial. Exception handling. You need to build a robust program. And the exam often ties these together, right? It's not just isolated skills.
Very often. You might get a problem needing, say, an OOP approach to manage data read from a file, maybe using a linked list or a tree structure.
And perhaps needing a recursive function somewhere in there, too.
Exactly. It's about integrating these skills.
Good. And just to hammer it home one more time, what's not included?
No low-level machine code, no assembly, no declarative programming like Prolog. Keep your focus high level.
Perfect. So based on past papers, what kind of tasks are likely?
Well, you'll almost certainly see tasks involving iterative algorithms and probably recursive ones, too.
Designing and using classes, definitely. OOP is central.
File reading and writing seems a constant. And of course, using those ADTs, stacks, queues, lists, trees.
So really, paper 4 is your chance to show off your practical coding skills.
It really is. Taking theory and making it work. Understanding the demands is step 1.
Okay, so let's get strategic. Where should students focus their revision based on recent trends, say 2022 to 2024 papers?
Right, looking at those, some patterns definitely jump out. OOP is consistently high priority.
Object-oriented programming, class design, methods.
And particularly recently, inheritance seems to be getting more attention. It's moved beyond just single classes.
So thinking about how classes relate, how they can inherit properties and methods.
Exactly. It shows a deeper understanding of OOP principles like code reuse and structure. Be ready for multi-class scenarios, potentially using inheritance.
Good tip. What else is high on the probability list?
Abstract data types, ADTs. Now here's an interesting one, linked lists. They haven't been the star in the very recent live papers.
Okay.
The syllabus explicitly covers insertion and searching algorithms for them, which makes them, a prime candidate for comeback.
Right, because they test understanding of pointers, dynamic structures.
Precisely. So definitely brush up on inserting nodes, beginning, middle, and deleting nodes, and searching. Know how those pointers change.
Got it. So linked lists are a strong contender this year. What other ADTs?
Binary trees are always important. They were tested, I think, back in November 2022.
Yeah, sounds about right.
But they're fundamental for hierarchical data, so definitely revise inserting nodes correctly, maintaining that binary search tree property.
And traversal methods.
Oh, absolutely. In order, pre-order, post-order, be fluent in all three. And notice how often recursion makes those traversals, quite elegant.
Speaking of which, recursion itself.
Almost guaranteed, it appears in so many contexts. Binary search, tree traversals.
Could be its own question or part of a bigger problem.
Either. Be ready to write recursive code and maybe even trace it. It's about that different way of thinking, breaking problems down. Base case, recursive step.
Okay. And file handling.
File processing, yes. Especially reading data from files, that's been a very consistent feature.
Taking data from a file and putting it into maybe one of those ADTs.
Very likely. And alongside that, exception handling, specifically handling file not found errors.
That was tested directly in June 2023, wasn't it?
It was. Shows it's important for writing robust code. Know your try, accept blocks, or equivalent in your language.
Okay, let's quickly recap the high priority list then.
Right. OOPP, focus on class design, maybe inheritance.
Linked lists insertion and searching are key there.
Binary trees, insertion and traversals.
Recursion in various forms.
And file processing, especially reading, with solid exception handling. Nailing these gives you a massive edge.
Brilliant. Are there any sort of medium risk topics to keep an eye on?
Yeah, a couple. Insertion sort is one. Bubble sort has shown up more lately, but insertion sort is right there in the syllabus. Wouldn't hurt to be ready to code it.
Makes sense.
Anything else? We sometimes see what you might call combined twist scenarios.
Ooh, like what?
Like a problem blending OOP with data structures. Maybe create a class that manages a queue, for example.
Or uses an algorithm within an object's method.
Exactly. Integrating concepts. It tests that broader application ability, which is closer to real-world coding.
So, main focus on the high probability stuff, but keep these medium ones warm in the background.
Precisely. A broader base is always good. It builds overall skill, too.
Definitely. Now, what about official resources? Where should students look?
Absolutely crucial. First stop. The official Cambridge syllabus. Chapters 19 and 20 are your Bible.
And the pseudocode guide they provide.
Yes, essential for understanding algorithm descriptions if they use pseudocode in the question.
And then, practice, practice, practice.
Past papers and specimen papers. There's no substitute for working through actual exam questions.
Understand the style, the timing, the mark scheme expectations.
And know the command words.
Yeah.
Describe, implement, trace. They mean specific things. Look at that list.
Okay, this is all great foundational work. But for that final push, maybe a plan.
We thought about that. How about a focused 7-day final sprint revision plan?
Love it. Lay it out for us. Day one.
Day one, algorithms. Get deep into searching linear, binary, iterative, A&D, recursive, sorting bubble, insertion. Know how they work, maybe their basic efficiency. Data structures, stacks, queues, definitely linked lists, practice adding, removing. Then binary trees, insertion, traversals. Code them out.
Day three.
Recursion day. Just immerse yourself. Find different recursive problems online or in textbooks and solve them. Build that recursive muscle.
Day four.
OOP focus. Design some classes. If you're tackling inheritance, practice that. Write clear methods.
Day five, the big one.
Mock exam day. Full paper 4 past paper under strict time conditions. 2 hours, 30 minutes, no interruptions. See how you really do.
Essential reality check. Then day six.
Review day. Look at where you struggle on day 5. Go back over weak areas. Specifically practice file I/O and that exception handling again.
And day seven.
Light review. Glance over key concepts, maybe your notes. But mostly, rest. Get your head clear for the real thing. Don't cram. Okay, as we head towards the exam, maybe some final strategic tips. Top 5.
Let's do it. Tip 1.
Master the fundamentals. Your algorithms, your data structures, know them cold. That's your foundation.
Tip 2.
Practice coding and testing constantly. Get your hands dirty on the keyboard. Test thoroughly. No substitute.
Tip 3.
Think before you type. Plan your approach. Sketch out the logic, maybe some pseudocode, before writing the final code. Avoid rushing in.
Tip 4.
Stay organized during the exam. Clear code, maybe some comments. Keep that evidence document neat and logical. Make it easy for the examiner.
And tip 5.
Manage your time. Keep an eye on the clock. Allocate time sensibly for each task. Don't get bogged down on one part.
Great advice. And remember, throughout this whole process, Zach's resources are there for you.
Absolutely. His YouTube channel for visual explanations, the website www.kazwithzach.com for materials.
And of course, the AskZ AI teaching assistant. That's us. Ready to help on WhatsApp, +923-3628-10241, or the chatbot at bit.ly AskZ chatbot.
We can help break down any A-level CS topic, clarify things, give examples, and we can communicate in any language you need. Personalized support.
So what's the final takeaway message?
It's simple, really. Smart preparation cracks paper 4.
Believe in the work you've put in. Approach it with confidence. Your skills have grown.
Consistent, focused practice makes all the difference. From both of us here, we really wish you the very best of luck for your June 2025 Paper 4 exam.
You've got this. Good luck.